everyone, and welcome to today's presentation. I'm excited to have you here. Today, we'll be exploring two key terms used in industrial plant design and operation: ISBL and OSBL. These terms are especially important in the context of engineering, procurement, and construction projects. To give you a quick overview, we'll break down what ISBL and OSBL mean, using simple examples like a refinery or a large industrial complex. So let's get started and understand these concepts that are fundamental to how we design and operate industrial plants. Let's take a closer look at ISBL, or inside battery limits. Think of it like the heart or the core of the manufacturing plant. This area includes all the actual machinery and units that are directly involved in transforming raw materials into finished products. For example, in a refinery, this is where crude oil is heated, separated into different fuels like petrol and diesel, or where other chemical processes take place. The key characteristic of these units is that they are directly involved in the main production process. They are typically grouped together within a defined boundary, which you might see on engineering drawings referred to as battery limits. To put it simply, in a crude oil refinery, the units that process the crude oil, such as the crude distillation unit, where the initial separation occurs, or other refining units, are all considered part of the ISBL. Understanding ISBL is important because it highlights the core operational area of the plant, where the main transformation of raw materials into valuable products happens. Now let's talk about OSBL, or outside battery limits. Think of it like the support system or utility services that keep the heart of the plant, which is the ISBL, running smoothly. These are absolutely crucial, but they don't directly produce the final product themselves. What does OSBL include? Well, it encompasses all the facilities that provide essential services to the ISBL units, but they are located outside the main processing area. For example, it includes utilities like steam generators, which produce steam for heating or other processes. It also covers power generation units, which supply the electricity needed throughout the plant, and water treatment plants that provide clean water for various processes or cooling systems. In addition, OSBL includes infrastructure such as roads, administrative buildings, warehouses, and storage tank farms. These storage tanks are used for holding raw materials or finished products, making them vital for overall operations. A key point to remember is that these units support multiple ISBL units and the entire plant as a whole. They are not tied to just one specific production process inside the ISBL. For instance, steam generators serve various parts of the refinery, a large tank farm stores crude oil or finished products, and the water treatment facility supplies clean water across the plant. So, in essence, OSBL acts as the backbone for the plant's operation, supporting, supplying, and enabling the main processing units to function efficiently and reliably. Why differentiate ISBL and OSBL? That's a great question, and I want to take a moment to explain why this distinction really matters, especially for those of you who aren't from a technical background. When we talk about ISBL, or inside battery limits, we're referring to the part of the plant that includes the core processes and equipment directly involved in manufacturing the product. On the other hand, OSBL, or outside battery limits, covers everything else: the supporting facilities like utilities, infrastructure, and other services that enable the main operations. Understanding this difference is crucial because it helps us accurately estimate costs, plan the project scope, and manage resources effectively. It also ensures clear communication among different teams, whether engineering, procurement, or management, by defining what's part of the core process versus what's supporting it. So, in the overall project, distinguishing ISBL from OSBL helps us optimize design, control budgets, and maintain a smooth workflow from start to finish. That's why I emphasize this point. It's fundamental to successful project execution and clear project management. Let's talk about project scope and costing, which are crucial for effective project management. First, Clearer budgeting helps us break down the project into smaller, manageable parts, making it easier to estimate costs accurately. For example, building the core processing units, or ISBL, involves specialized equipment and complex engineering, which tend to be more costly. In contrast, constructing a water treatment plant or a tank farm, known as OSBL, has different cost considerations. When it comes to contracting, it's important to recognize that different contractors often specialize in different areas. Some might focus on ISBL work, like process engineers, while others might be experts in OSBL tasks, such as civil engineers for infrastructure or utility specialists. Choosing the right contractors for each part of the project ensures expertise and efficiency. Lastly, scheduling plays a key role. The design and construction timelines for ISBL units can be quite different from those for OSBL units. Understanding these differences helps us plan better and avoid delays, ensuring that each part of the project aligns smoothly with the overall timeline. All these aspects, budgeting, contracting, and scheduling, are interconnected and vital for keeping the project on track and within budget, aligning perfectly with our overall project goals. Let's take a closer look at responsibility and management in our process plant. First, defining roles is crucial because it clarifies who is responsible for what. Typically, process engineers focus heavily on the ISBL, which is the core process area. Meanwhile, civil, mechanical, and utility engineers often take the lead on OSBL. Those are the external support systems like utilities and infrastructure. Next, risk management plays a big role here. The risks associated with the core process technology, or ISBL, are quite different from those related to utility supply or environmental compliance, which fall under OSBL. Understanding these distinctions helps us allocate resources and safety protocols appropriately. Moving on to operations and maintenance, there's a clear operational focus based on the area. Operators working in ISBL are mainly concerned with the specific chemical and physical processes happening there. In contrast, OSBL operators manage utilities, storage, and other infrastructure outside the core process. Safety is, of course, a top priority everywhere, but the specific safety protocols and hazards can differ significantly. For example, working around a high-pressure reactor in ISBL requires different precautions than managing a steam generation plant in OSBL. Recognizing these differences ensures that safety measures are tailored to each environment, keeping everyone safe and operations smooth. So, in summary, clear roles, understanding risk distinctions, and tailored operations and safety protocols are key to managing a complex plant effectively. These points tie directly into our overall goal of safe, efficient, and responsible plant management. Now, let's talk about permitting and regulations. As you can see, environmental permits, safety regulations, and building codes often have different requirements depending on whether we're dealing with core processing areas or utility and storage zones. This distinction is crucial because it influences how we plan and execute the project. Understanding the difference between ISBL, or inside battery limits, and OSBL, outside battery limits, helps everyone involved, from financiers and management to engineers and construction teams, to communicate clearly and work more efficiently. By breaking the project down into these logical, distinct components, we make the complex more manageable. This approach not only streamlines compliance with various regulations, but also enhances our ability to plan and operate the facility effectively. It's all about creating clarity and structure, which ultimately leads to smoother project execution and better operational performance. This is a key part of how we ensure success from start to finish.